In episode 41 of Mobycast, we continue our conversation on the birth of NoSQL and DynamoDB. In particular, we pull back the covers on DynamoDB, examine its architecture, and discuss why it's such a popular solution for internet-scale databases. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Hello and welcome, Rich and Chris, another episode of Mobycast.
Hey guys. Hey John. Hey Chris.
All right, how's it go? So I would say, how's it going? And let's talk about our weeks. But we're on episode 3 now of what's been some of my most fun times here at Mobycast so far, which is just talking about DynamoDB and Chris's history in the internet data storage world. This time we're going to steer sort of back away from Chris's personal story, which I'm kind of sad about because that's so fun for me and so interesting. But we do have to cover some technical stuff and hope that people can learn on this podcast. So we're going to talk about DynamoDB a little bit more and really get into the internals of what it is and how it works and all that stuff. So I think that an obvious place to start with a conversation like this is just about NoSQL and just why NoSQL. It's been talked about to death, but let's just at least gloss over some of the highlights of that conversation. Go ahead, Chris.
Yeah, so we touched on this with the previous 2 episodes. What are the challenges of being internet scale, the types of data that's being collected and whatnot? So maybe just as a recap, kind of just talking a little bit about what has been the evolution of data. And, previously before the internet really became where we needed to have internet scale databases, SQL and relational databases definitely ruled the world. Maybe the interesting thing to consider with that is that for the most part, SQL, it came about as a way to optimize for storage. When it was developed, storage especially was very expensive. And so by going with a normalized data model where you basically aren't replicating the data, you could save on storage space, right? So this is one of the primary motivations behind building these relational systems in SQL. So optimize for storage because storage is really expensive. The data is normalized so you don't have duplicates and you have these multiple tables of the data and they're connected together through keys. And then they're also built to scale vertically, right? You don't, in order to handle more load, you get a bigger machine or you add more storage or you add more memory or C power. But, here we are another 20, 30 years into the future. And now storage is really cheap and we have lots and lots of it. So this was one of the reasons for going to NoSQL. NoSQL is definitely more of it's denormalized data. So rather than making references to your data in other collections, you just keep it all together, basically kind of like as an atomic unit. So there's some duplication of data for sure, but again, storage is not nearly so much of an issue as scalability and the ability to scale horizontally. So that was really kind of what drove this evolution from SQL to NoSQL. It's just basically just realizing that the constraints were now different. The economics of the resources that are being used are different. And this model came about.
Right. I remember memes before they were called memes, kind of joking at people that were going to Mongo, a long time ago, that were basically making fun of like the fact that people were using it for not internet scale problems. And, it's like, are you internet scale? And no, a lot of people were not internet scale. So it was that scalability that was the first driving force behind it. And wasn't it something like Groupon or something that was one of the first users of, Mongo in particular at scale?
Maybe. I mean, I don't recall exactly, who some of those first marquee customers were for Mongo, but definitely, it did kind of, it was probably like 2010 around that time frame, I think, when kind of Mongo appeared on the scene.
Yeah, it came after CouchDB, but I think it came a little stronger and with a little bit more, it was like more buttoned up and ready for people to use.
Mm-hmm. Yeah, I think they probably had more resources behind them and they were able to iterate more quickly and get some of that market recognition and share that comes along with it.
Right. And so we were going to talk about DynamoDB here. And, what's interesting for me about DynamoDB is that it's been around longer than either of those. And we went kind of deep into the history of that before, but I think it's only this year, it could just be me and I'm projecting on the world, but I think it's only this year that people are realizing that Dynamo is not an ugly stepchild of Mongo. And it's not like a newer entrant and it's not a half thought up thing, but it's actually the OG of NoSQL database, and it's really very good and managed in AWS. I think people are kind of realizing this, talking about it a lot, and making the decision to use it. So let's talk about what it is.
Right. Yeah. So, MongoDB, just like, DynamoDB, just like MongoDB, think of them as, for the most part, they're document stores or they're key value stores. So the data is denormalized. You're basically fetching something based upon some kind of key, and you can think of it as just a bag of data that's coming along for the ride. So it's a document or it's a value type thing. It's also, DynamoDB in particular is definitely geared towards event-driven programming, which is, really kind of a very popular pattern, and we've talked about before on previous episodes of Mobycast. It's very popular, and it's going to become even more popular. It's designing distributed systems that are complicated. Going to an event-driven model is kind of key in order to reduce the complexity. So DynamoDB has native support for that, and we can talk a little bit about that as we dive into it more. And then, of course, DynamoDB is designed to be very, very, very scalable, very performant. One of the things at reInvent this year that they pointed out, a single table in Dynamo can handle 4 million transactions per second. That's a lot.
No way. I was not there to hear that. That's amazing.
4 million transactions a second. So that ends up being what, like a 250 million a minute?
Right. Yeah, that's
right. That's
unbelievable. That's
every 4 minutes doing 1 billion transactions.
Yeah.
Right. So it's very scalable, very performant, right? And that's the power of scale out, right? That's the power of horizontal scaling and partitioning and sharding. And that's why these systems are really good at this. And they can do this partitioning and sharding because of that NoSQL data model, right? It's the data is denormalized. It's not normalized. When it's normalized data, like it is in a relational database system, you have this network of connections and links that just make it very, very difficult to isolate that data and to partition it up. This is really what NoSQL systems really good at. Hence why they're really good at internet scale databases and the kind of data that we need to store for these internet applications.
Great. So I think I want to dive into something here that's always confused me a little bit. And that's that. So when you're working with a NoSQL database and you know that there's a lot of data that's just replicated in there and you kind of don't worry about it too much because, that's being normalized is not important to a NoSQL database. It's just not how they work. But what I kind of get tripped up on is keeping all that data in sync so what I'm saying is if you have, say, an attribute that's in 10 or 15 different kinds of documents that's spread out all over your NoSQL database and you need to update just that attribute, to me, in my mind, that means you've got to go find all those documents and update that attribute. And I just kind of trip over that. My mind just trips over that and says, how could that possibly be performant? And I don't know if you could just help me not trip over that a little bit. And I realized I didn't prepare you for that question. It could be a fairly difficult question.
Yeah, it just really depends on, what data is changing, the kind of data that you are replicating and whether or not that needs to be updated. Are you doing this for query reasons, for building indexes? That gives rise to other techniques. So I would say there are definitely techniques that you can use that you don't really have this problem, right? You can design yourself around it. It doesn't make sense, right? To say okay, I'm going to go update the title of a document. And that means I have to go now make 15 write operations because I've replicated that across 15 other documents in my table. And you wouldn't want to do that, right? It just doesn't make sense. So you would design your model and kind of your data so that you weren't having to do that, right? So you can pick and choose what's the data that you want to replicate and keep together. And then do you want to keep that data that may be changed that is common? So, I think a good example of this would be you have a list of maybe types of users or something like that. So you store the type of user and maybe you want to keep a friendly label for it. It's a string, right? So you have admin, you have read-only user, you have a normal user account. So you have, various different types of users and labels that goes along with them. And then you may include that label in each one of your user documents. So you can replicate that across, right? You could have 1 million users registered in your system and they all have that as their label. Mm-hmm. But chances are you're not going to change that, right? You're not going to update the title for the admin user necessarily, right? the same thing with like, if you kept track of like states and the postal abbreviations for them, you could duplicate that data, but chances are it's not changing and you don't have to worry about that. So
right, or if it does, you can do it with one big go. But like this exact problem is the exact thing that I get kind of wrapped around the axle with when I think about NoSQL database design. And I realize we do want to get back over to DynamoDB and what it is and how it's designed, but just bear with me for a little bit. So yeah, you've got your admins, you've got your normal users, you got your read-only users, and they each have different label. And I would imagine the kinds of queries that you would want to do would be, okay, give me Steve. And what kind of user is Steve? Steve's an admin. Okay, cool. Steve can do this. But then the other kind of query you might want to do is tell me all the admin. And if you only have the admins as an attribute under the users, then that's a painful query, right? You have to go get all of the users and then look at all of their role types. And then, okay, now I can tell you who all the admins are. That's not a good way to doing that query. But then, so you're like, okay, we're going to not worry about duplication of data. And instead we're going to have all the users and their role is going to be in the user record. And then we're also going to have another document that just has at the top level, it's going to be each user type. So there's going to be at the top level, it'll be here's the admins, here's the normal users, and here's the read-only users. And then under each one of those nodes will be a list of every user or their IDs or something. So then it just seems to me that there could be a problem having both of those sitting around, having that data stored in both of those two different ways. If like, you see what I mean? Like, doesn't it seem like that?
Yeah, well, I mean, this is where indexes come into play for sure. So like if you wanted to, if you had a query pattern where you just had to go get all normal users or all admin users, you would just index on that particular attribute in your table, right? And that would end up being a very fast and very performant operation.
Okay, so an index is essentially just going to take all that data and store it in another way. It's going to store it in like another order so that you can get stuff in the order that it's stored in. And if the index needs to be kept up to date and all that, and that could be expensive, but that's fine. You can let the database system take care of that, and you don't have to. Okay, got it. Yeah. Okay, that makes sense.
Yeah. So indexes are super important, right? With things like DynamoDB, and really kind of understanding like what are your query patterns and where do you need indexes and how do you do that and things.
I think, and I could be wrong on this, but I think that when I used Mongo on a big project and it was in like 2010 or 11, it did not have index. Like it wasn't a feature. I could be wrong, but I think they just didn't have it. And that was what was killing us. We were like, oh my God, these queries are so slow. So let's just duplicate the data. Okay, now they're fast again. Oh, now we have a horrible mess of data on our hands.
Yeah, I started using Mongo in 2012 and it had index support. Right?
Interesting. And it could very well have, and it could have been that we were just, missing them both. But yeah, indexes make a ton of sense.
Yes. And there's lots of support for that with DynamoDB. And maybe this is a good time to kind of talk about just like the overall terminology for DynamoDB, right? So like with relational systems, Dynamo has this concept of table. The table is basically a collection of these documents or these key value things. And so those particular components referred to as items. So you have tables. Tables are composed of 0 to n items. A table must have a partition key. So this is really important, kind of identifying what is the partition key for your table. It's a primary key, right? It uniquely identifies an item. But what's really important about it is that it's determining the data distribution for all the items that are going into that table, right? Like this is what is being used to shard the data, to partition the data. So you want something that is uniformly distributed and fairly random, right? So you wouldn't want a partition key on like a status value or like user type or gender. Like those wouldn't be good partition keys, but something like a UUID would be a good choice type thing. So partition keys, again, this is the primary way that you're going to uniquely identify the items inside your table, and it does determine your data distribution and how well the data can be distributed. It can be fanned out and distributed across all the storage resources that are there. In addition to the partition keys, you also have something called a sort key. So sort keys, you define keys that basically create indexes that allow you to sort items within that particular partitioning. There are some other terminology and we can talk a little bit more about this as as we have time. There's the concept of a global secondary index. And what this is a way to provide an alternate partition key. And these are pretty powerful, but they're also really expensive. I believe the limit is you can have 5 of these, a total of 5 of these.
When you say expensive, you mean like just in terms of how much extra compute resources it takes, or storage resources it takes, or memory it takes?
Yeah, I mean, this is creating duplicates of your data behind the scenes, right? Because it's basically saying like, I'm going to use a different partition key. You can almost think of it as like, it's almost like a whole different database. It's a copy, but it's shuffled in a totally different way, right? So that's what a global secondary index gives you. So the expense there is that you have your primary table partition key gets updated first, and then after that, it has to make the updates to the global secondary indexes. And so that's where some of that performance and cost comes into play, is just the updates of now you have to go do all the global secondary indexes. And there is latency, right? Because those are eventually consistent updates. It's asynchronous, which is what you want. If it was synchronous, it would be your performance would really go down quite a bit. So there's some latency there. And then there's the concept of a local secondary index, which is similar to the sort key as well. It provides you an alternate sort key, but it's local to the partition it's on. So those are some of the, overall terminology. But at the end of the day, it's pretty straightforward and simple. You have these tables. These tables are composed of items. The items, they do have schema, but the schema is flexible. That's the primary principles of NoSQL. And again, it's kind of up to you is how you use this data, like how structured you want it to be and how flexible it needs to be. And then you have these indexes and keys that determine how the data is going to be partitioned, and then how you want to access it in the most efficient manner that you need.
Yeah, pretty straightforward and familiar for people that maybe have not worked with NoSQL databases but come from the relational database world.
Indeed, yeah. I mean, it is very similar. I mean, just the relational database world, you're going to look at your query patterns and you're going to create indexes on certain columns in your database, right? Because you want to be able to query on those, and you don't want to do a full table scan, which means I have to go look at every single item in the table in order to find out whether or not it meets the search criteria.
Right.
That you want to create an index on it, right? So that you can very efficiently retrieve those values. And so the same concept applies with NoSQL and with Dynamo and with its indexes.
Right. So there's a whole section on architecture and components that we want to talk about, but I'm thinking we can save that for the next episode, because before we talk about that, there's one just thing that's bothering me that I don't know about DynamoDB. And it really is, for developers, it's the key. It's the crucial thing. How do you query a DynamoDB database? Do you use SQL, or do you use a proprietary DynamoDB query language? And if it is a new thing that you have to learn, a new query language, how hard is it? And how confident can you be as you're learning it that you're writing good queries? And as you answer that question, like how confident can you be, just think about how hard it is to be confident that your SQL queries are good. Like, it takes a few years of experience before you're like, okay, that's a bad query. Yep. And this is going to be a better query.
Yeah. So, I mean, it's, NoSQL databases are definitely built for modern apps. They're very developer friendly, and you don't really have to go learn, a new query language. For the most part, it's, it depends on, again, what it is that you are storing. If you're using it as a key value store, obviously your queries are based upon like your key. Like, so you're saying, here's my key, go fetch this value. For documents, again, you can reference those by key, by its partition key, or if you want, you can do queries where you're saying, go get me all the documents where the user is, a super user. And in which case you're using something that looks a lot like JSON, right? So it's going to be very, very familiar to developers. You're just going to say like, here's my JSON expression for, this is the attribute that I'm going to go search on, and for every attribute that matches this value. And then you have there'll be like certain placeholders for operators. Like, do you want to do and? Is it an and query? Is it an or? Is it, greater than or less than? So some just very familiar concepts for putting together Boolean expressions for going and querying this data. So there's that. And then there's a very rich ecosystem of tools and information to kind of let you know how your queries are doing. So, just any DynamoDB has the support. Mongo has it as well. You can go analyze your queries. You can get reports on slow running queries, what's taking a long time, and then also just hints on how to go fix it. So there's a lot of support there.
Cool. Well, that's good. SQL being what it is, it's definitely a weak spot for a lot of folks. Hopefully that it's a weak spot that people address because SQL is not going away. But to have double the amount of weak spots because of the NoSQL database that is just as difficult of a query language as SQL would be really burdensome for the whole community. So it's good to hear.
SQL is very robust, very extensive. There's very few people that understand every function, every component of the language, right? It's being constantly added to as well, right? So it's like you go look at the documentation for, say, like Postgres's version of SQL, what it supports, and it's like, oh wow, like there's 20 different ways and operators I can use to go roll up aggregations, and it's like, okay, what do I do here?
Totally.
Do it, right? Versus not nearly as expansive in the NoSQL space, right? So it's much more constrained. And again, it's kind of, reflects the data model, right? The data model is simpler, so therefore the query language is simpler.
Excellent. Yeah. Well, I think we'll wrap it up there. Definitely a good first look into how Dynamo is put together. And I think we'll probably do one more next week just to talk about really how Dynamo sit in AWS and what's going on there. And, because it's not an application you install on your own server. So what is this thing and how is it put together? So we'll talk about that next week.
All right. Thanks, guys. Good talking with you.
Good talking with you too. And thanks for putting it together, Rich. Talk to you next week.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/41. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.